Okay. So 14 on 392. We have the integral, and the seventh root of x is x to 1 over 7 dx. I have to do that and change it from a radical into an exponential notation. So it's x to 1/7 plus 1, which is 8/7 over 8/7 plus a constant c. I have to flip the denominator, so it's 7 over 8, x to 8 over 7, plus a constant c. So what does this represent? It's a family of functions whose derivative is this function, also called the most general antiderivative. Is this okay? Do we need more examples?
This is fine, thank you.
Thank you. Good. Next topic, next question, anything you want to work on?
Can we do sketching asymptotes and rational functions?
Sure. Sure, that is on chapter 3. Asymptotes and rational functions, 3.3, page 305. These are, they're using everything, asymptotes and graph, I think. Yes, so from 35 through 44. Beyond 44, these are combinations. These are not rational functions. They are combinations of exponentials and rational. And we already looked at one product. We just had x times e to the negative 3x a few minutes ago. It came from a different chapter, but a different section of this chapter, but it's the same. Good? Anyone?
Can we do 44?
Yes. Let's take a look at 44. Perfect. Good. So 44 on page 305. And that is f of x equals x plus 1 divided by x squared minus 2x minus 3. Okay. So they want the whole thing exactly as we did with that x e to negative 3x, which was quite interesting. Good. So for rational functions, especially for like this one, for example, I always start with a domain. It's a must. But in this particular case, the denominator is factorable, so I will factor it immediately into x minus 3 and x plus 1. which means that I have, first of all, I have to state two restrictions, and I'm going to get my table going. Do not touch anything before you state restrictions. So f prime of x, f of x, and f double prime of x. We know that the function does not exist at -1, and the function does not exist at 3. And now I'm allowed to simplify. When a factor goes away, it means that x equals -1 is a hole in the graph, and the simplified form is this, which means x equals 3 is a vertical asymptote. This is the function we will continue with, 1 over x minus 3. So when I plug in -1, I have 1 over -4. The limits at infinities, we know they are 0. How do I know? Well, the limit of 1 over x minus 3 when x approaches infinity or negative infinity, doesn't matter, is 1 over huge. And we know that 1 over huge is 0. So y equals 0 is a horizontal asymptote. Now, left and right, I have to determine limits. So the limit Sx approaches 3 from the left, and the limit Sx approaches 3 from the right of 1 over x minus 3. I know it's 1 over 0 in both cases, but 3 from the left is 3 from the left is 2.9, which makes this negative infinity. 3 from the right is 3.1, which makes this positive infinity. So negative infinity and infinity. And I also have to plug in 0, and I get -1/3. I exhausted everything about the function. Limits left and right of the vertical asymptote, the whole, -1, -1/4, the x-intercept, there is no y-intercept. I'm sorry, the y-intercept, there is no x-intercept, and the limits at infinity. There is nothing else I can find about the function from the function itself. Now I have to study the first derivative and the second derivative. So I will look at the function in this way. As we discussed a long time ago, when the numerator doesn't have x, this is a better and easier option. So f prime of x will be negative x minus 3 to -2, and the second derivative will be 2x minus 3 to -3. This one is a number always forever less than 0. No critical numbers, meaning no max min. Now at this point I have to stop and make sure that these two rows work well together. If they don't, there is no way I move on to the second derivative, because I haven't accomplished what I needed first. So from 0 to -1/4, that's correct. -1/4 to -1/3, that's correct. -1/3 to negative infinity, that's correct. From infinity to 0, yes, that's correct. So it shows that the function is always decreasing, and my numbers are decreasing as well. Now, when I look at the second derivative, this is 2 over x minus 3 to the third power. But to the left of 3, this number is negative. So the whole thing is negative, and it does not hold water, or is concave downward. But if x is greater than 3, this is positive. So it will hold water. And the function is not symmetric. That's all I need. I don't care for anything else. Only the table gives me what I need. So I start with asymptotes, always. Okay, this is an overkill because it's already there. At -1, I have -1/4, and that is an open point. At 0, I have negative 1/3. And the left-hand side of the vertical asymptote is very clear. It's coming from approaching 0, going through the hole, crossing the y-axis, and coming down towards negative infinity. Very nice, very clear, smooth ride. On the other side as well. And it opens downward, and it's decreasing all the time. On the other side, also very easy. Opening up, coming from positive infinity, approaching the horizontal asymptote. And this, and I'm going to write here the original function, which was x plus 1 over x squared minus 2x minus 3. Any questions on this problem? Any questions? Is there another topic that we want to look at? Anything else? Anything else? Just making sure that I have my pages in order, because when I scan them, I want you to have them in order as well. Yes. Anything
Can
else?
we,
Yes?
can we go over related rates?
Related rates, very good. Awesome. Yes, that's at the end of chapter 2, 1, I think. Looking 1.a, high order derivatives. No, it's under applications. It's at the end of chapter 3, actually, yeah. Yes. Yes, it is. So it's page 364. Very good. 364. Do you have a problem for us?
Review question 8.
You said 8?
Yeah.
Sure. Let's look at 8. We have y equals 5x minus x squared. And they say find dx over dt when x equals negative 2. And dy over dt is 2.5. Very good. Okay. So when I'm asked to find something like this, there is an important information in the question. It means that x is a variable. I'm sorry, x is a function of t. That's why I put a little dot underneath, just to signify that this is not a variable. Also, when I am given something like this, as information. Then I know also that dy over dt is this, but it means that y is a function of t. So these are functions of another variable. So when we differentiate the left-hand side and differentiate the right-hand side, we have to remember that these are all functions. Y is a function, x is a function. So the left-hand side will be dy over dt, and the right-hand side will be 5 times the derivative of this, which is dx over dt, minus, I'm differentiating a function, I bring down 2, I multiply by the function to 2 minus 1, times the inner function prime. So now, they're asking us to find dx over dt. I have to factor out dx over dt from these two terms. So dy over dt, dx over dt, 5 minus 2x. I'm solving for this. How come? That's what they want. So it's this over this. And then I can plug in all the given information. So first, dx over dt equals this, as is, dy over dt over 5 minus 2x. And now I'm just going to plug in the information. Dy over dt, they say this one is 2.5. And they are giving us x as being negative 2. So therefore, dx over dt equals 2.5 over negative 2 times negative 2 is 4. 4 plus 5 is 9. So I could write it as 25 divided by 90 and simplify by 5. And I get 36. I'm dividing by 5. Sorry. How did I get 36? Nobody knows. So it's 5 divided by 1, 8. Sorry. I'm calculating something, but not what I see. Something else. We can approximate if we need to, but 5 over 18 is perfect.
Can you explain how you did the x squared again?
X squared.
Yes.
A function to a power prime is n times the function to n minus 1 times f prime. So 2 times x times the inner function prime.
Thank you.
So power 2 comes in front, 2, f to 2 minus 1, which is 1 times the inner function prime. Better?
Yes.
Perfect. Good. Other topics? Anything else?
Can you go over number 8 on 162?
Say it again. I heard 162, but I didn't hear the number.
Problem 8.
8. Yes, very good. (162). Problem 8. Very good. So we have to differentiate. I'm assuming that that's what. Yes. Okay. So y equals 4 the square root of x plus 3 multiplied by x cubed. Good. So first of all, we have to apply the product rule. So either you write dy over dx, or you write y prime, or you write f prime of x. It all means the same thing. So I'm differentiating this. S4 times 1 over 2 the square root of x, because 3 prime is 0, times x to the third plus the first function times the second function prime. So the first function prime is this, times the second one plus the first function times the second one prime. We can further simplify, but we're not going to get too far. So we can try. I'm going to factor out x squared. So this is 2x over the square root of x, because I simplified the 2 and I only have an x here. And I factor out x squared, so it's 3 times plus 12 the square root of x plus 9. It's not going to make too much of a difference. I can find the least common denominator. But I'm happy with this, but if we want to further simplify it a little bit, we can. So this is x squared. The least common denominator is the square root of x. So 2x plus 12x plus 9 the square root of x. So finally, I can only say 14x plus 9 the square root of x and x squared over the square root of x. There is no need. This is for now good enough.